By looking at a graphed line, we can determine whether the slope of this line is negative or positive. To identify a positive slope, you look at the top of the line. If it moves to the right, it's positive slope. If the top of the line moves to the left, then the slope is going to be negative. So let's take the example of the first graph. We see the top of this line is moving to the right. So therefore it's going to be positive slope. Now what you're basically comparing this to when we say you move to the right is this x-axis. Everything to the left is negative and everything to the right is positive. Let's take a look now at the second graph. The top of this line is pointing toward the left. Remember, you're comparing it to the x-axis, to the left, and therefore anything moving to the left that way is going to have a negative slope. And taking a look at the third example, in this area here, we may think that this slope is going to be negative, but remember, it's not where you are, it's the movement. This line, the top of this line is going to move all the way up to the right, all the way through this area here. And that means it's going to be positive slope because it moves to the right. Instead of looking at the graphs, let's go ahead and look now at the actual equation. We have here y equals negative 2x minus 5. Now the slope is a negative 2. The slope is negative. Now if the slope is negative, I know that my graph line is going to look just like this. It's the top of the line is going to point to the left. So we'd be able to know when we graph the line whether we're correct or not by looking at the sign on the slope. Over here, in this example, y equals 2/3 x minus 2/3. Here we see we have a positive slope. So I know that when I go to graph this, the actual line, top of the line, is going to be pointing toward the right. And this gives me a good idea of what my slope is going to look like. You need to know that the slope of a horizontal line is 0, and the slope of a vertical line is undefined. Now either you have to memorize this, or try to understand how this occurs to remember it. If you have a horizontal line, 2 points on it, the y values will be the same. Since we're looking at the slope, it's the change of y over x. The y's are the same, so it's the numerator that's going to come out to be 0. 0 over another number is okay. If we come over here and we're looking at vertical line, on the line are 2 points. Now since it's vertical, the 2 x values are the same for the points. The x values are in the denominator. Since they're the same, when you subtract them to get the change in x, you're going to get a value of 0. And 0 can never be in the denominator. So therefore the answer here for the slope would be undefined. We can use the slope to determine whether lines are parallel, whether they're perpendicular, or neither of the above. To refresh our memory, parallel lines look like this. The slopes will be the same, and the lines will never cross and touch each other. They're always equidistant from each other. Over here, looking at the slope, you would have the same slope, 3 and 3 in the M position. Talking about perpendicular lines, that looks like this, and when the lines cross, there's a right angle. And their slopes have to be negative reciprocals. The negative reciprocals mean negative, you change the sign. If it's positive, you make it negative, and vice versa. A reciprocal means instead of 2/5, you're going to flip it and make it 5/2. So we come over here to our example, and we have a positive 1/3. So it has to now change to a negative, and the 1/3 has to flip to be 3/1. But 3/1 is just the number 3. both of these have to occur. It has to be both the sign has to occur to be changed and it has to be flipped. If neither of the above occur, they're not parallel or perpendicular, but then the slopes won't be the same and they won't be negative reciprocal. An example here, you're going to get the question. Determine if lines are parallel, perpendicular, or neither. These are your two equations. You just have to look at the slope. First, this is a negative slope, so the other one has to be positive. Yes. Second, it's 5 over 2, so the other slope has to be 2 over 5, and it is. So therefore, they are perpendicular lines, and they will look something around the order of that. We're being asked to graph a linear equation and to use the slope and y-intercept to graph it. Taking a look at the equation we're given, we can see it already is in the y equals mx plus b format. So we know that the slope m is going to equal negative 3 over 5. Now remember that the numerator is the change in y values. So that means y values are up and down along the y-axis. The negative tells us that we're going to move down in the y area, and we're going to move 3 places down. The 5 relates to the difference in the x values, and that's positive. So we're going to move along the x-axis positive to the right 5 places. Now we're going to look at the y-intercept, and that is negative 2. Now that means in the ordered pair, it's in the y position and 0 is in the x position. Now we come over and look at the graph, and where do we begin? I know the slope where I have to move, negative 3/5, but where do I begin? Well, folks, B stands for begin. That's why it's called B. Begin here. And we begin at 0 and negative 2. So we're going to come over, and we're going to go 0 and negative 2 would be right here. And yes, that is our y-intercept. And that's where we begin our movement. And our movement is in the y direction, negative, which is down, 3 places. And also x now to the right 5 places. So we're going to now go down 3 and over 5. And that's where our second point is going to be. And we'll connect the dots, and we've got a line. Notice arrows at the end of every line to show that it continues all the way to infinity. Don't forget that. And we're going to label this line y equals negative 3/5 x minus 2. So anything on that line is going to satisfy that equation. Nicely done. This is the end of this video.